If we try to be a little bit more quantitative, suppose I had here a charge +3. And here I had a charge -1. Here's -1. And I want to know what the field configuration is as a result of these two charges. So you can go to any particular point. You get an E vector which is going away from the +3. You get one that goes to -1, and you have to vectorially add the two. If you're very close to -1, it's very clear because of the inverse R² relationship that the -1 is probably going to win. Let's, in our mind, take a plus test charge now. And we put a plus test charge very close to -1. Say we put it here. Even though +3 is trying to push it out, clearly -1 is most likely to win. And so there will probably be a force on my test charge in this direction. The net result of the effects of the two. Suppose I take the same positive test charge and I put it here, very far away, much farther away than this separation. What do you think now is the direction of the force on my plus charge? Very far away. Excuse me? Why do you think it's to the left? Do you think -1 wins? So you really think the -1 is stronger than the +3, because the +3 would push it out, and the -1 tries to lure it in, right, if the test charge is positive. Imagine you all the way in Mass Avenue. You think that this distance matters? Who thinks the force is in this direction? Who thinks it's in this direction? Very good. You've helped them, really. The force is obviously in that direction, because if you're very far away, the field will be the same as if you just had a +3 and a -1 somewhere here, which is +2. So if you're far away from a configuration like this, even if you're here, or if you're there, or if you're way there, clearly the field is like a +2 charge, and falls off as 1/r². So therefore, if you're far away, the force is in this direction. And now look, what is very interesting. Here, if you're close to the -1, the force is in this direction. Here, when you're very far away, maybe I should be all the way here, it's in that direction. So that means there must be somewhere here a point where the E field is 0. Because if the force is here in this direction, it ultimately turns over in that direction. There must be somewhere a point where E is 0, and that is part of your assignment.